So I'm going to continue on with this peer review, and this one's going to be much less polished than the previous one, but I want to sort of talk through these next set of problems. So the first thing we're looking at here is the function that parses the input. It's going to read in a file. Let's just see what that file looks like. So it looks like this, where there's a map followed by a blank line, and then there are movements. So the map is going to generate an in-memory representation of this. The parser is going to do that. It's going to turn this into a two-dimensional set of vectors, and this is going to be a one-dimensional set of directions. So the code is fine. It's doing the job, but is not as rusty as it could be. And it's not just for the sake of writing Rust code for writing Rust code, but for writing Rust code in a way that is much easier to maintain, much easier to manage. So just to start talking about in that direction, one thing that we often do in Rust with iterators is we don't create vectors and then manually push content into that. We create iterators and then extend the vector from that iterator. So to illustrate my point here, the line here that's reading in the characters, essentially this is reading in things that go across here. Actually, this is going to be a direction one, so it's reading all of these directions. I would rather see this written like this. So I would probably say let all directions equal, and I'm going to turn this into this from lines.characters, map, and we're going to map each individual character, and we're going to match on that C. And I'll let Copilot fill in the rest because it's going to be right based off of what it sees above. This is creating a description, an iterator. So all directions is going to be an iterator. And it's doing a transformation of all the characters and the lines into a direction based off of this sort of match statement. This is the rusty way to do it, and is very maintainable. It might look very different from this, but once you start learning how to use iterators and transformations to manipulate your data, things become much easier, especially when you start using them as sort of computational generators to generate content on the fly rather than iterative transformations. But we'll probably see that when we see the business logic implementation. So then what this does is you just then extend your initial vector by these directions. So this code here is the same as this. And like, to be honest, I'm not worried about like the lines of code. Yes, there are fewer lines of code. Some of that is just because of the blocks that are here. It's actually probably about the same number of lines of code, but we're not iterating through things manually and pushing. We are generating something that represents, once it's evaluated, all of the directions in that line, and is arguably a much easier way to work on this. And actually this needs to be changed. This has to be an OK. And we would have to, I'll get into that later. I don't want to jump ahead. This is actually not quite the right version of this, but let's just jump ahead to compare it to what I have written, and we'll see how these sort of compare. So let me do this side by side. And here is my version. Let's go back to the original. So on the left is their version. On the right, right here is my version. And again, I'm not necessarily concerned about the lines of code. that certainly factors into it, but let's just look at what I'm doing here. So in mine, I take the string. This happens to be I get it as a string, as opposed to a set of a buff reader like it's done here. But I use split once to split this into two separate strings. So it's going to find this new line character and give me one substring here, one substring here. And split once will fail if it can't find that anywhere. And we properly report it with this nice shortcut with OK or else and the short circuit operator to handle that error. We generate the map content. So map here is going to be a vector of cells, and movement's a vector of movements. It's exactly what we want in here. But mine, let's move this over so you can see the whole thing. We take our map content and we take the lines, that's this, and we perform a mapping operation on that for every line. And there's actually two mapping operators. This is the outer loop and this is the inner loop, the same thing that's here for this for loop and this for loop. And the operation that it does is it turns a character into a cell using try from. And try from is going to be written for cell as this. So we implement the try from crate on cell. Cell is the object that we are storing into our map. In this case, we're storing an enum. But try from knows how to convert from a character into this enumeration with the ability to fail. So if we go back here, we're converting all the characters into cells. We use collect, and collect, if it is a result of something, is going to be able to propagate that error. So we're propagating the error of this result, we're propagating the error of this result out of there if there's any line that doesn't match. So here's all of our map content. Here's all of our movements. Movements is really the same thing, except we're flat mapping it because there could be more than one character on the line, but that's semantic issues with the problem. So I much prefer this, and as you go down the Rust train, the Rust road, whatever you want to call that, you're gonna see this a lot more. And once you start embracing transformations with iterators, your life gets so much easier to deal with. And I'll show you as we continue on how this can be even better. Now, this, especially for Advent of Code, is used so often that I can do this in a sort of single statement. I say parse grid, and I just say what kind of grid I want, which is going to be, the grid is, the input is here, and I should be able to do that. Let's see if that builds. It does build. And it should test fine. Let's run our tests against this. Oh, unwrap, invalid parsing. Why is this unwrapping? Invalid cell. Oh, because it's trying to parse the whole thing. I really need to parse the map content. Isn't testing really nice? So once I fix that, we should be good. All my tests pass. So by just calling parse grid on map content, because Rust knows what my type is that I'm parsing into, it will do this for me. So let's just look at that real quick. So parse grid, and this is going down a little bit of a rabbit hole, but parse grid is going to use parse grid I, which takes an iterator version of something. So I know that our grid is going to be in line, so it's a string we're passing in for lines. And here's that same version of it, except it's generic. It's generic over the type, and it's generic over the error that could be propagated by the the failure of being able to convert it. And the conversion is done, well, parse grid calls parse line calls try from. So it's sort of a nested set of generics to be able to do this work. Because I also want to be able to parse a line where I'm getting just the values out of that. So again, this is useful so often that I can parse a grid with the map content, and all of the errors in the types get either elided and propagated as needed. Really, really clever way of doing things, and I never have to worry about it doing the wrong thing. So in reality, this is now replacing all of this, arguably through some generic functions that are reusable, but verifiably correct and always going to do the right thing. Cool. That's it for my second little peer review here on parsing, and a few more things, and then I'll get into the body of the actual code, the business logic. So stay tuned for the next one. Maybe, I don't know. That's what the YouTubers are supposed to say, right?